Hi there, welcome to another podcast with Masood Alam. The podcast series is The Architect's Den, and today we have with us lead data scientist Catherine on the call. I will let Catherine introduce herself and talk about what she's been doing in the past, what she's doing now, what excites you about your job. So over to you, Catherine.
Hey, uh, hello, and thanks for having me on. So at the moment I'm a lead data scientist. My background is actually I started off in mathematics, um, mainly because just found it easier to understand numbers rather than words. Um, and then from there, I actually studied control systems engineering. The interesting thing about control systems engineering is actually machine learning applied to control systems in engineering vehicles or anything like that. So that's where I actually learned a lot about machine learning. That's my first introduction to machine learning itself. After that, I spent a year abroad in Asia teaching mathematics before starting my PhD in neuroinformatics itself. So there I focused on modeling brain signals that you get from you actually get them via these large magnetic resonance imaging machines, but not the images, but rather the spectroscopy signals, which is a slightly different experiment from the same machine, but allows you to actually get chemical details of an area of the brain itself. So that was actually quite exciting. Um, and the trend you can see through here is that I've tried to do something that's applied but mathematical. I just enjoy the activity of applying mathematics to problems itself. Thereafter, I worked in a trading company in Germany. I worked for a network corporation in the UK and also for a research institute in the States. And now I am a lead data scientist. Um, in the UK.
Right, really excited to have you on board. And for the audience, the topic we are exploring today is metadata cataloging, the new advancements in technologies around the cataloging space in general, and we will be targeting a couple of approaches that we believe are going to take place in the near future, or if not, they're already taking place somewhere. And at Catherine's experience in LLMs and AI would be very, very relevant. So let's kickstart with the basics, right, before we jump straight into it. Catherine, if you can maybe, um, talk a little bit about explaining what the core challenges any organization face when they talk about data visibility, accessibility, the data discovery in theory, and what roles a data catalog plays when it comes to improving an organization's data governance, compliance, for example. So let's start from the basics there.
Okay. So, yes, I'll start from the basics here. So, at a very basic level, and especially when we're speaking of medium sized to large organizations, probably one of the biggest challenges these organizations tend to have is when they have a specific problem, there might be a buzz, C level, say, I need these numbers because we have a client and can you get it for me? And then you realize you think everybody, your colleagues think, I'm sure we have that data, but you cannot remember where it is, what it was called, and so on. And this all comes down to how you've tagged your data over time. Because usually what tends to happen is as companies grow, you start small, you get bigger, and you're always in a rush for one reason or the other. Even if you sit back and are careful, you might be faster, but when you're in the middle of this, you don't think about that. So everybody rushes. They get their data, quickly do a calculation. The name of field one is 01. The name of field two is, um, you will see weird names, is 27681. What does that mean? You don't know. So at the basic level, tagging is a problem. And even sometimes when you actually have, maybe you have very conscientious people who do that very well, then there's the issue of, in the beginning, too many firms do not have uh, a basic standard of where they will store their data. So they will have a mix of Excel files, CSV files, maybe some might actually have a database, but don't have time to use it and set it up. They've not recruited the data people to deal with it because, unfortunately, and you wouldn't believe this, for so many years in many companies, data isn't really, it's not important. You can just quickly pick something and use it. No, the investment usually goes everywhere else in IT except data itself. So you see these very, very simple basic problems because we think they're very easy. We don't care to make sure they're in good structure. So we don't tag, we don't have, some companies tried master data management, which was very good, but most don't do that. The discipline is not there. You only have a bit more discipline whereby the slightest mistake costs you money. And that's one of the things I learned from my experience in trading companies because they are serious about their data because you can tell that everything depends on that. So I would say that yes, tagging discipline around how you store your data. And then, of course, that bleeds into governance because if you had some degree, even a little bit of governance or any norms about your data, everything I mentioned before wouldn't be happening. They would be in a slightly better state because you have somebody that's saying, hey, you can't, keep your data there. You can't do this or that. It needs to be in a certain way. So there was always that lack of governance. That's so you don't have that leadership there, and then everything else just is haphazard in itself. So so you could say very simply that lack of governance was an issue and that cascaded into everything else that companies do itself.
Right. Okay. So that's very interesting point there. Um, so you touched base on tagging. We'll come back to that. But when you said that the governance and compliance is really very important, do you think the catalogs can really help improve your compliance, especially for highly regulated organization, example gambling or banking sector? Uh, I mean, what roles the catalog plays in the compliance side of things?
So that is actually one of the most critical, ways you could um, enforce compliance. Okay, why? I'll give an example. So,
Right.
depending on the degree to which your metadata catalog, how good or bad it is, because of course, with every tool you have poor ones and you have excellent ones. But imagine there are, maybe you're working in a risk firm or a hedge fund or something like that. Now, depending on sensitivity of some things you do, there's certain people that can and cannot access certain things. If you have a metadata catalog, which in many cases is more or less an API to everything, all the different types of data you have, depending on how you set it up. You have it set it up maybe in a certain federated way such that you can control who has access to what. You always have a clear view of who is the information asset owner, who are the stewards, and who is everything else. Everything becomes open and clear to especially those who have overall of authority over your data. They know who owns what at any point in time. They know who to go to if there's anything wrong with certain assets in a certain area of the company. So if you want the simplest technological, auditable way to understand or know what you have and who's responsible for it, a metadata catalog is probably one of the best ways you can do that.
Really, really interesting. So, I mean, yeah. So it appears that a catalog is quite critical to organization, not just discovering and understanding your data, but also useful for compliance side of the business as well. So
Yeah.
that's exciting to understand. So I wanted to come back to tagging, and you kind of expanded on that. That tagging is a very critical component of any modern any modern data catalog. So what actually you mean by tagging? Can you give an example by saying that, how the tagging is going to help us? Like,
Okay. So we can think of tagging, and I know I used it in a very general way earlier. We can think of tagging at different levels. So first of all, if let's first think of the maybe your data level, raw data. So maybe your data
mm,
tables and maybe your text files and things like that. Okay. So you have let's say we have a data file, for example, or maybe a database with their columns in there. And maybe or maybe not, you have correct labels in there for each of the fields. Now, one of the things you can do with some data technologies is that you can tag each of your whether you have data files in a data lake, a database, you can tag each of those files automatically as you load them up to give the definitions of all the fields that are in there. So you might say, okay, isn't it enough if might have the name, column DOB or date of birth, and the next one is state and so on. Maybe, but state where, you know,
mm,
if I'm living in Botswana, I don't know what states you're talking about, and I work for your international firm. But if you tag it, and many of these, for example, I don't work for Amazon, so I can say this. For example, AWS allows you to tag every item when you upload it, and to correct it as well. So every time I upload a table, I add tagging with the definitions of each of the columns in the table. And if it's a text file, with a description of what it contains. That way, if data architects or any other architects in the firm are crawling for data, trying to understand where they can find something, when they come through the assets of my Amazon account, hey, they've got the information they need. So that is already helping the organization in terms of getting good data. Because at the end of the day, no matter how superb, and I know we'll come to this later, no matter how
mm.
superb your models are in terms of your active metadata um, itself, if everybody has done a poor job in terms of tagging or labeling and so on, it will take a long, long time before you're able to build good information from what you're getting itself. Does that make sense?
No, that's absolutely making sense to me. But I think for the audience sake, we might need to bring in a follow-up question around
Yes.
how that would actually happen. For example, technologies like knowledge graph and AI are trying to solve some of those challenges when it comes to translating your data. But are these technologies good enough? Because there is a problem of hallucination with AI, and how would these technologies really help you achieve what you're trying to suggest over here with tagging the data?
Uh, Okay. So the important thing I should start off with is that if you're starting with poor data, artificial intelligence is not going to help you.
Right.
So this is very important to know. And I'm going to so I will start from the beginning and I'll explain each of the different types and what they can do. So you're an organization, you're building up. You maybe let's say maybe we're an e-commerce firm or maybe a supplier. Let's say we're a supplier. We get in, we ship all sorts of goods from different countries. We're based in the UK. We ship goods from different countries, and we want to keep track of information that we get from the different firms. So maybe they supply us many goods. A table per firm. Let's take one table. We have the inventory of what they supply us. Okay. Now, I know that a lot of discussions that people have in terms of how machine learning might help is that, oh, it can check the table and it will find out what kind of data is in there and give it a name. People need to be careful because if you completely, so foremost, one of the best things, if you want to try and learn from text data, the problem is this: a lot of language models are not that great, regardless of what people think. Because you think about it this way: in terms of large language models, so let's start with maybe the ones that's to do with chatting, for example, whereby generating responses, so on.
Right.
It's not that these models are smart. The issue, what is happening is that these models have been trained on a lot of discussion data from the web. Okay, millions and millions. So in mathematically, what's happening is that the model is finding patterns in terms of what words come after the other. Now, a lot of the way, for example, as we speak English, most of the time when we first have a meeting, we'll say, "Hey, hello, Monsieur, how are you doing?" You'll say hello to me. So over time, how many different ways can we say hello? The pattern, the model will pick it up. Okay. Or I'm going to school, I'm doing this, I'm doing that. It's easy for it, that pattern just repeats itself over time. So yeah, it learns the pattern. So when it comes across some text and something is missing, I think, hello, this is Masood. And if the task is classify each word, it would guess that Masood is a name because
Right.
of the pattern that has come there. It's not that because it understands anything, it does not. It's just that after so many examples whereby people more or less have the same structure of how they say hello to each other, the same structure of how I'm going to school, the same structure of the president said blah 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 blah. After a while, it just guesses. Yes, this is a name, this is a place, this is and so on. Then when you introduce something completely new it hasn't come across before, and if it's out of the context that it has learned, then it would make a mistake.
Right. Okay.
So the problem, there are no hallucinations. It's just by design. These models will make mistakes because by mathematical design, they're designed to learn the patterns that have existed,
Right.
nothing else. And that's the thing to be aware of.
Okay. So you
So
so
go ahead.
sorry for interrupting. So you said that hallucination is not the right word. It's
It's not.
right. Okay. And it's making a mistake on purpose because it's built this way.
It's built this way. So the reason tech people like to use words that the idea is to give the impression that the model is smarter than it is. S- it's purely that it's for marketing and advertising purposes, which is wrong because it has given people the impression that these models think for themselves, but they do
Right.
not. The models do what we design them to do. And sometimes, well, a lot of the time, some of these designs don't work. This is why we have so many machine learning algorithms because none of them can work in every case. So we have support vector machines, we have neural networks, we have we have computational neural networks. We have so many. Why do we have so many? Because each one is only good in certain respects. And then when you apply them to a different problem, they do not work very well.
Interesting. Very interesting. So I think that was very, very helpful in understanding what actually AI is doing under the hood and how it can produce a relevant solution for us for tagging. But I think there, one critical piece of information we missed over there was
Yes,
where would the knowledge graphs comes in?
come in.
Yeah,
Great. So, so what can we do considering what I've just said in terms of generation? You don't have to use generative artificial intelligence models. No,
right.
that's not necessary. So let's give one example. Let's say you have tables and sometimes you have some tables have a name of, let's try date of birth. You have data from different places. Oh no, let's go for company name. You have the data from different places and you have company in there and there's a field called maybe company registration. In another organization, maybe they use the field name CR. Another one might have company underscore registration. You don't know each other, so you just name it what you want. You have all these data coming from different companies, and you probably don't realize that these tables have some common data in them, which you can pull together to get more intelligence. Now, let's imagine now that we are in an active metadata situation, or maybe not quite active yet. You're trying to improve. And what you're doing is you're running a model each day, okay, to try and classify the information, or no, the field names. So you're doing two things. First, you're profiling the content of the field, right? And then it seems as if they have similar profiles. That's one. And then you have the names as well. And then because of that similarity, you decide, okay, I have checked this, the profile. The profile suggests to me that these three tables or databases, it seems as if they have a common field, although the names of these fields are different. So I'm going to make a suggestion because another reason that you're making this suggestion is due to the context of the tagging from the information, right? You think they've been classified as company data and so on. So this is where three things come into play. One, you never upload your data without a field name, right? It's important. It's just
Yeah,
crazy. You can't use it if you don't have a field name. It has
yeah,
to have a field name. Two, it's important that you tag your data one way or the other. If you don't, okay, there might be a suggestion there, but it's risky because you could take the option of checking what's in there. Well, with company registration, it may or may not be easier because it's a ID. So you profile it, you could guess. If it's text, it's very risky because then you have to use a generative model. So let's stay with identification numbers for now. So every table should have field names. Even if the field names are poor, there should be field names. Two, the company should ensure that your fields are tagged or your tables are tagged with descriptions. Because if they are, the better your machine learning models will be in terms of learning. So if your tables and your data sets have those two things, then we have two things to play with when we move. Now I will move to machine learning models. So what can we
right,
play with? One, we can use token classification models to try and classify the tags of your data sets. That's one. So this is why tagging is important. And in the beginning, it's not automatic. There needs to be something. You can improve it, right? You can improve
mhm,
it over time. But if you don't have table names and you have no tagging whatsoever to start off with, it's difficult because then it will make a suggestion. You would have to set it up as part of, and actually you always have to set it up as part of augmented. I will come to that later.
mm,
But it will make suggestions that might not be good. And then you will have to go around in circles over and over again. And in the end, it's a case of I might as well write something to start it off as well. So
Mm,
table names and tagging are critical. So, and then your token classification model would classify the words and the tagging. So imagine those three tables with different company registration field names, but each of them with tagging written in different English, but what are they saying? Basically, they're talking about company registration number. Huh. So token classification model would then um, classify the words for these fields. Okay, now then we move to the next step whereby if it does its job well, due to the context, because token classification takes place in context. Remember what I described earlier,
yeah,
whereby I was talking about we in the end, there are only very few ways I can define company registration number. There are only very few ways I can say I'm going to school. There are only very few ways I can say hello to you. And this is what's going to be happening here. So I've got CR, company registration number. I've got company underscore registration. This is the blah, 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 is the company registration number. So it would then classify that token in each case as now, this will depend on how you've set it up. It will classify it as probably organization registration. Great.
right,
So you've got for those three tables organization registration, organization registration, organization registration. Then we move to knowledge graph because,
right.
yeah, this is making sense now.
Yep,
Because
yep,
now what you have is that with depending on there are not many different ways you can set up a graph model, but
yeah,
usually you linking from hey, I've got this from this sentence here. This has organization registration, organization registration, organization registration. It's going to the same place. You've got your mini graph. Now, after this step, you have two options. At the moment, I think probably the safest is you have an augmented system. It suggests before you accept it into your knowledge graph database, maybe you want somebody to see it, look, like, that's fine, accept, and then it goes on there. So the knowledge graph comes after the token classification, and the token classification comes after your latest data has come in. And so that's one kind of simple option. And what I think would happen over time as generative models get better is that if you have a text file, you'll be able to have an abstract summary, which will suggest, oh, because of this, we think this is about tax or this is about something else. If people want to start doing that now, I would say be careful, do not invest too much money in this yet. Keep an eye on
right,
it. Maybe have an augmented separate system just to understand how things are going. If you design the way you use models very well, you can easily take one out and replace it with a new one. So as long as
mm,
if you have excellent engineers, then yes, why not try it out? But just understand that at the moment, they're not great. If anybody wants to really, really understand their flaws, I would suggest to read Emily Bender, a linguist, and Gary Marcus. He actually used to own an artificial intelligence firm as well. There are many others as well.
right. Interesting. Interesting insights. Right. I mean, yeah, I think that makes a lot of sense. Knowledge graphs and AI working together to deliver tagging, and there are different kind of tagging you talked about. So really, really appreciate that. So I think that brings us to another topic, which is very, very relevant here as well. That about the large language models that we have uh, been talking about, and then there is a new concept emerging where we are looking into automating the metadata as well. And this comes to the data stewardship. It used to be data analysts who used to do the data stewardship in the past, but data stewardship terminology emerged in the past few years recently, and it has become the responsibility of data stewards to do the data management bit on the catalog, which includes tagging the data, writing up the metadata for the data available. But the data is ever increasing, and it's becoming very, very difficult to do this manually, especially for an organization that is medium to large size, and they don't really have any data catalogs, and they want to use AI systems for innovation, for example, but without having a knowledge of the data, obviously they can't do that. So it
Mm,
becomes extremely difficult for large organizations like that, which do not have a data catalog,
yeah.
how to do the data stewardship, because it's a big mess. So what do you think that a role of LLMs uh, is in for the modern catalogs, or for organizations to build in-house functionality using LLMs to automate their metadata?
There are, okay, there will be two parts to this.
Right.
So if the data in question is numerical, for the moment, it might be tempting to suggest to use a different machine learning approach rather than LLM. And I will come to that. Now, large language models might play a part because I agree with you there. There is this issue whereby over the years, people have collected so much data and they do not know what is in their text fields. And you could end up, I mean, you can read through thousands of lines to try and understand. I wonder what this is really about. It's difficult. Now, this is where language models come in, and this is where things get a little bit tricky because if language models are flawed, then what will be the best option? Well, the best option then will be then to have an augmented solution. So, as I mentioned a few minutes ago, so imagine you have, and this tends to happen with your data that's from the environment. You have this table, you have a few fields, so you know that yes, this might be geographic points and so on, and then you get to these 3 or 4 columns and they're all text. You're not quite certain what they could be. Sometimes it might just be words, and maybe you notice that, it seems as if there are only a few combinations. It's not completely text, and others it's really, really text explaining something. So there are 2 or 3 things one can try here. For the ones whereby you have blobs of text, whereby it's discussing a lot of items, after just a brief check, you could do 2 things. Number one, try token classification with one of your, so depending, also this will be depending on the type of organization you're in. So if, for example, I'm working for a water waste company, okay, so it could be that I want token classification in relation to that has something that identifies chemicals and seaborne diseases and all these other things to identify things. Then you can also use large language model to create to just go through each of the lines and try abstract summaries. Now, it might not give you very good information, but you're just checking because maybe some of the blobs contain 200 lines, 100 lines, you don't know. What those two would do, summarization and token classification, is give a general understanding of what might be in those tables. So then you might find out, oh, I could actually do 2 things here. I can build knowledge graphs and I can generate a short summary, metadata summary. And after that, you can actually decide what else you want to do with it. So one thing I know we've done in the past is you try and extract certain types of information from it to find out, is this about disease? Yes or no? Even though it's text, but just by running through it. So But if you do those two first in an augmented way, token classification in relation to the domain area in which you work, because that might allow you to then build knowledge graphs and then summarize, apply summarization, which at first might seem inefficient, but you never know. And it's the computer doing it, not
Yeah,
you
yeah.
itself. And then just to find out whether or not you can get clusters of similar summaries as well.
Right. Okay.
And there. And then because after that, you can have an overarching summarization to create a name for it itself.
Right.
But as you can tell, for anything that is kind of text like that, you would you will need a kind of smart collection of 2 or 3 steps to get the best from it. Don't think you can just apply one model to it. So, but
Mm,
yes, but remember the token classification is a large language model. The summarization is also a large language model. So token classification language, so it would be something such as a lecture, and we can have that in the show notes after and program notes afterwards. That models such as a lecture, um, Distilbert, Roberta, these are all large language models that are used for classification. And then for summarization, you have models such as Pegasus, T5 itself. These are all language models. Just make sure you use models from organizations that have a history of developing models. Don't just pick up any random model.
right. That makes total sense. So before we close this question and move on to the next part, so do you think that uh, the inaccuracies have impact on the automation part of the metadata, or how accurate do you think the end output would look like? Because uh, any organization would not want to invest that much time, money on building, uh, building or tuning a model, and the result is 60% accuracy and 40% of the data it generates, the metadata it generates is flawed. So it becomes another marathon exercise to find that flawed information and fix it. So again, the human element and the human involvement is still there. So
Yes.
what do you think? The kind of accuracy levels and the problems around those areas.
So one thing I've mentioned a lot recently is when you first meet up with your data scientists to decide whether or not you want to develop a model, whether for summarization or classification, or you want to use large language models, it's absolutely critical that you also have business metrics. Now, these business metrics, so I will give a simple example. So, in the performance sense, let's say you're classifying, and let's say we are a news organization. We get notes from the field. It's absolutely critical that the names, no names all names are excluded before these notes go forward because these are from special sources. Now, you don't know the name all the time, and sometimes you advise that people send notes to you using different types of what do you call it, aliases and so on. But basically, you want all names removed. There
Right.
can be no mistakes, right? So in that case, you say any you would put a price on false negatives. So it's not just enough that, oh, how many false negatives do I have? Oh, three. What is the cost of each false negative? £1.5 million. Oh,
Hmm.
okay. What is your budget, your lawyers and everything can you afford per year? You have to weight your false negative rates in relation to the liability you think you can accept. So if it's only one per year, you have to take that into consideration. So in that case, you must If your false negative rate is any higher than you can accept, then you reject that model. There we
Right.
go.
Okay.
Now, if it's close, because the thing is, many of these things have to be, especially in the area of text, they have to be augmented in the beginning, unfortunately, especially if you're in a high risk situation.
Right.
And even if it's augmented, you might say, hey, mistakes should not exceed maybe one or two false negatives per year. And then you might decide, okay, but it will be augmented and we have somebody checking. But then decide, what of the one day when that person is tired? Is the very day
Exactly.
that her name
Yeah.
goes through. So
Yeah.
this is where business metrics are critical. And it's not just the technical ones, you have to have that. And you have to make a brutal decision as to whether or not, if it's a critical situation, if you want to use machine learning models. If it's high risk, and you can't afford to, don't use it.
Right. Right. So great power comes with great responsibility. And
Exactly.
this is what I've been reading when I've been using Linux since 2009. And before that, at my uni days as well, since 2006. The first message you see is, when you convert yourself to root user, it says great power comes with great
Great
responsibility.
responsibility.
But I never
Yeah.
understood what actually it means. But today I've got some ideas that what the consequence could be if you want to use AI, but you haven't figured out your business metrics. Thank you very much for pointing this out. It was very, very helpful. So moving towards the end of the podcast, there were a couple of very good questions I wanted to ask ask yourself. Um, it's not really very technical, but it's more of what do you think about the landscape? And the first one around that is, do you think that AI, based on what we've discussed just now, would eventually replace data stewards, in the near future? We're talking about automating metadata, automation of tagging using knowledge graphs, AI, and building custom models and all that. So where do you think we are? Are we close enough to replace stewards altogether using these technologies, or do you think that there is still a future for data stewards? Because there would be a lot of data architects or modelers who want to become data stewards. Some data engineers, they fancy doing data modeling and metadata tagging as well. It's quite an interesting job. I've done that in the past myself. So do you think that it is still a viable career, or stewardship is going towards its end because of the emergence of AI?
I actually think at the moment stewardship will become more important, partly because
Okay.
of what I just mentioned, that companies will still want to try and make use of machine learning models, which is fine because you don't know when a good one will come along. So this means that, because remember, machine learning models depend on the knowledge of the people who understand the domain in which people are
Mm,
working. That's one. If a data scientist that doesn't work with the business to understand the problem and develop models accordingly will develop the wrong solution.
right.
Who will pick up the errors is the data steward. And they will have to be sharper than ever because
Right.
when these solutions are coming in, you first have that false excitement that everything is okay. Ah,
Yes.
but within which environment was this tested? It's very controlled. But remember, as your data comes in over time, things change. So let's take, for example, February, so what 2022 was when Ukraine was
Mm,
invaded. A lot
yes.
of the news bulletins were, about Ukraine, Ukraine, Ukraine. Then over time, it died down. That's data
Mm,
drift.
right. Right.
Something else comes into play, and then that would die down, and then there'll be something else, and that would die. So we always suffer from data drift. Now, the model would have been developed at a certain point in time with a certain type of data.
Mm,
Models must always be retrained because data changes. And when we're dealing with text problems, you know, the difference between Let's say, keep in mind the text problem. Now let's think about rainfall. Let's say in a farming area we have a gauge that that measures the rainfall for us. Nobody, and it has a sensor there, so you know the level.
Mm,
So if I have a prediction, so imagine we have a forecasting model for rain, and I forecast
right,
that there will be 20 millimeters of rain tomorrow. If I make a mistake, you will know by the day after tomorrow because the sensor would have sent us the latest one. We don't need to wait for a human. It's not the same with text. Who's going to read the text and check? Who's going to give feedback to check that everything that has been classified in the text sent is correct or wrong? And if it's wrong, has to make the correction, and that will be fed back into the data holding place so that it can be prepared for the next retraining. So the work of the data stewards is going to become more complex, and they're going to have higher responsibility. They're not just going to disappear. The shape of what they're doing will change, and their responsibilities is going to be a bit more.
right. Okay, that's interesting. So how do you want to break it down? Like the next 5 years, data stewardship is going to become more complicated role because of AI producing a lot of errors for them to work with. What happens when AI becomes mature? Because I was hearing Sam Altman, the inventor of OpenAI, that there are 5 stages according to him, and the stage one was the chatbot stage, which took several years, to exit. So he says that now AI has entered an observer state. So which means that AI is becoming more observant. So it is trying to learn what's happening around it. And he predicts that we will exit the observing state of AI very quickly in next few years. And then third and the fourth stage will come. I can't exactly remember what he meant by the third stage, but the fourth phase, he said that he expects closer to 2027 or 2030. Uh, and that would be innovation stage where AI would think of its own and develop new solutions, which means it will think like human because humans can develop new solutions. So what do you think that, given the rate at which AI is spending, if I'm a graduate today, do you recommend that I should adopt data stewardship as a career, or is it something I really need to think about it again, from that perspective?
So the problem with the way technology bosses
Mm,
talk about artificial intelligence is that it's completely at odds with what artificial intelligence is. So I noticed there's a
mm,
phrase that people mention a lot, which is quite strange to me. Artificial intelligence is developing at a fast rate. No, it is not.
right.
The mathematics of artificial intelligence has hardly changed. In fact, quite curiously, one of the key reasons, well, there are two. One of the key reasons why it's much more popular to use machine learning models now is thanks to computation power, not because of the mathematics of artificial intelligence, which amazingly has hardly changed. And what I was going to mention a few seconds ago, the curious thing is that the mathematics of transformers is simpler than the mathematics of computational neural networks. And an hypothesis I had about this is that that's probably partly because, and this probably accounts for why models that or architectures that depend on transformers need more data because you're trying to use much simpler mathematics to learn patterns, okay, itself. The mathematics of computational neural networks depends a lot on um, convolution matrices, which is much harder to understand than the straightforward matrix multiplications that are common throughout transformers. It's just one multiplication after another, after another, after another. Even the term self-attention that some people have heard about, that is just about softmax matrices. So what troubles me is that many of the leaders in the business part of artificial intelligence are using language to make machine learning to be much more powerful and important and special than it is. It doesn't, these models, they do what we tell them to do. It's either, depending on the company, is either encoded opinion, encoded mapping,
Hmm.
encoded decisions. It's it would do the way any model will predict and behave depends on the data you give it and how you design the algorithm itself. It's nothing beyond that. It's why I can't remember his first. I think his name is Judy Appel. He's a very super mathematician in the field of causal machine learning. And one of the things he mentioned, I think 2 or 3 years ago, maybe longer, was that the sad thing about the field of machine learning or artificial intelligence is that everything is still about um, fitting. I don't know if you remember in school, whereby you imagine you have an equation. So maybe y equals mx plus c, a straight line.
Yeah, yeah,
And you have this fitting model. So you moving things up and down bit by bit until you can get the right solution. So so maybe you're using this equation to describe the relationship between weight and height, for example. And you're trying to, so you have all your y's and your x's, and you're wondering, what is m? So you change it bit by bit. So it's a
yep,
fitting approach. That's exactly what we're doing with even
yeah,
large language models today. It hasn't changed. It's fitting. So you have all this, you're shifting things bit by bit until you get to a point whereby, hey, if I put in Afghanistan, it tells me it's a geographic point. If I put in Masood, oh, it's a name. Hey,
right,
I've got my model.
right,
And there it is. So what troubles me about what Sam Altman is saying is that the language he's using gives the impression that these things are their own selves. They're not. They will misbehave if we forget to end the while
right,
loop or anything like that.
true,
What what I think can happen is some group at some point, maybe in the next year or two, might decide, hey, I think we've got a better way of developing a natural language processing model that can be used for token classification. If that happens, yeah, once again, the role of a data steward might be different. It
right,
might be simpler and more enjoyable, or it could be a nightmare. So everything really does depend on what all data scientists do in terms of developing new models itself, not what none of these machines will grow up into something new. No, everything depends on the research that goes on over the next few years. If we are able to move away from this fitting and fitting and fitting and similar, we just making equations bigger or smaller or changing them around. If we don't move beyond that, then these models, some of them will work well in some situations and some will not work. And of course, we will be in a situation whereby, I mentioned before that we have support vector machines, neural networks, many other models, um, nearest neighbor. We have clustering all sorts of clustering algorithms. The same will happen here. People will come up with new ones. And then at some point, things will be better. Do I know what will happen in terms of if If we do not throw too much money at the current design and try and find new ones, things will be okay. If we waste a lot of money on this same design, even though we know it's flawed, then things will not succeed. So everything depends on that. Yeah.
Right. Okay. So that's a very elaborative answer, Ed. If I summarize it in one or two lines, it's more about in the marketing what the founders of those AI companies are saying, but the research is not really actually moving at that pace compared
Exactly.
to compared to what they're saying. They're probably using more data to refine their models rather than the research on the mathematics part is moving forward. So I totally get that bit, and hopefully the audience understands that as well, because every second day there is a new AI model that says that it can work like a PhD, it can do this and it can do that. So it's basically they are using more GPU power, much more data to maybe train their model, much more clean data. And that's how they are making all the improvements and using the marketing terminologies to say that AI is going to become this and that in the next few years. So,
Yeah.
but the face of it is that the research uh, is not moving that fast. Obviously, it takes 4 years for an individual to do a PhD, and this is where all the research happens in academics, and it's quite a slow process. So
Yeah.
thank you for that. Last question for you, and that's totally up to you if you want to answer that or you skip that. But it's quite straightforward. But I'm really curious to understand that what you think the future of metadata cataloging looks like. So in my view, all of these technologies that we have discussed uh, is kind of the direction for the future. But in your view, maybe we are jumping too soon in this, or maybe this is the right time we should at least try some of the things uh, using those technologies in the cataloging space that can actually work well for us. So, what do you think the future looks like?
I think it I think the future is good and will be better if people try and use things now, and so that researchers can get a feedback in terms of what they need, what they want. Because remember, a lot of models are developed as a result of a problem that came up,
Right,
right? Especially the most useful ones. So when there's no problem, you have something that's looking for a solution itself. So I would say start using them, and just be aware of what each type of model can do. So, for example, large language models, you can use them for a question and answer type of task. You can use them for token classification, which I mentioned a lot. You can use it for summarization and then sentiment analysis.
right,
Okay, so when you think about that, and then think about another thing, I know one thing to remember is that for text from specific fields. So physics, chemistry, blah, blah. Define this, blah, blah, blah. Define that, blah, blah, blah. It's so standard. Language models would do well in that area. It's different
right,
from I speak in a certain way, I use certain words, you speak in a certain way, you speak in words. Now, try and get a language model, try and summarize essays written by everybody in Scotland. How do you think that would perform compared to summarizing physics text, which is more or
right.
less standard? And those are the things you need to think about. If you're working in a specific area,
Hmm.
environment, and so on, and you have that rich standard data, train your model on that. If you want to use it for question and answer or sentiment and so on, it's slightly more standard. It's different from trying to train a model to understand all the emails in your organization. Ha! You might have a problem. We don't all talk or speak in the same way. And we are not in the House of Lords where the language is a bit more kind of similar and standard there. So, yes, try it. Make sure your engineers build flexible, changeable model or systems so that if one module is not working, you just take that out, you plug in a new one. So, the engineering is there to help us to be able to have flexible designs so that if one thing doesn't work, we can replace it very easily with another. So that's the main. I think that's the main thing. Try it,
Right.
and and things will be okay.
Right. On that note, Catherine, thank you very much for your time. Really very interesting conversation. I hope the audience is going to love it. There was a lot of stuff around the benefits of AI and the criticism, and the kind of models we should be using. Some terminology has been corrected, like hallucination. We talked about the mathematics of it. We also explored how the future looks like for data stewardship and catalog in general. And we also explored what's the best way forward when it comes to using this technology. Start small, think big. That was the message. And once again, thank you very much for joining us on this podcast.
Thank you. It's been great.